Okay, so here are the proprietary plugs for the OBDI protocol. And again, this was used from right around 1985 to right up into the introduction in 1996 of the OBDII. So as you can tell, I have 5 connections here, and this one's for GM, this one's for Toyota, this one is for also Toyota, I know this one's for Ford, and then this one is for Chrysler. So each one had their own proprietary plug, which kind of made it, you know, from a mechanic standpoint, you'd have to have all these tools and all these different plugs, and then you'd have to have a way to read the diagnostic software off of said vehicle. So the one we're using today is GM's version. This is the ALDL, or the Assembly Line Diagnostic Link Protocol. That's the one that GM used to plug into their vehicle, and we're going to use this scanner. But I do have OBDII vehicles, and again, that's from 1996 up, and they use the specific OBDII plug, and this is on every vehicle. They don't change the different plug type between OBDII. It's more of a baseline universal code and connector systems. So you can see this one does OBDII, and it says EOBD and CAN. CAN is just a way that manufacturers use to transfer information via a CAN bus. So here, all these codes are specific to the manufacturer, and we're going to go over some of those. And then this, the OBDII style, uses what's called P-series codes. Now, P-series codes are universal, and we're going to go over that as well. So this is a typical P code. So it would be P0010. If you were to get this when you plugged in this device and search for that code, the first, they call these generic ones, is intake camshaft position actuator circuit open bank 1. So each car, if it's a V-series car, will have a bank 1 and a bank 2, similar to if you see exhaust. If you have dual exhaust, it'll be bank 1 and bank 2. Each vehicle, unfortunately, is kind of different where they call bank 1 and bank 2. If you have a horizontally opposed engine, bank 1 can be the front, bank 2 could be the rear, vice versa. If you have a longitudinally V-series engine, bank 1 could be the right, bank 2 could be the left, etc. And then they kind of give you a generic description. Bank 1 camshaft and the crankshaft have a variation in mechanical timing. The problem occurs when the engine experiences high RPM. The ECM does not properly adjust valve lift at high RPM. So they say, these are your symptoms, car runs poorly, blah, 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 blah. Possible causes, sludge and engine oil. So this would probably be, oh, and there it is right there, a VVT, or a variable valve timing engine, meaning as oil pressure increases, the cams can actually move to open or operate a second set of camshafts, higher lift, etc. Faulty OVC, internal damage to ECM, all that good stuff. The codes on OBDI are quite different, and we're going to show that right now. Now, I didn't go through each manufacturer for the plug that we have, whether it be Ford, Toyota, Chrysler, and GM. I'm only showing the GM side of things, mainly because we're going to be doing it on a GM vehicle. But this is the ALDL plug that they're showing, obviously the ground, the diagnostic terminal, etc. Now, you don't actually need an OBDI code reader similar to this Bosch, boom, to read these codes. What we're going to do is plug in our code reader, and then if it has any codes, get the codes off of that. We're also going to read some of the information that the ECU is giving to our code reader. But if you see here, we can just ground terminals A and B, and that's these two. And with the ignition on and the engine not running, the system will enter diagnostic mode. And in this mode, the computer will display a code 12, that's 3 times, by flashing the check engine, the service engine soon, or the malfunction indicator lamp light. The code 12 consists of 1 flash, a short pause, and then 2 flashes in rapid succession. So what you would do is, let's say for instance you had a crankshaft position sensor or circuit problem. After you get a code 12, you would leave that short plugs in there, and then it would flash a 1 followed by 9 short flashes, and that would indicate your crankshaft position sensor or circuit. So you would go then to the crankshaft position sensor, see if there's a frayed wire, it's broken, the sensor's dead, etc., and then you would replace it as needed. Here's on 35, idle air control or the IAC valve circuit. So What the IAC is doing is opening or closing to allow more air to come in through the system as the same level of gasoline is coming in during initial startup and idling. So if that's stuck open and it needs more air, obviously because the throttle isn't open to allow the butterflies to open, that's where you're getting the airs from the IAC. You might be too rich. If it's stuck open, you might be too lean. So a lot of times guys will just take those off, clean them out, put them back together and see if they work. Sometimes they're just dead. So, but this is for GM, and I will put a link in the description below where you can find our procedure, and I'll probably leave this picture up in the video towards the end, just so you know, if you're watching this video and you don't want to search, you can just pause it and then go through some of these. These are pretty good. OBDI isn't as good as OBDI+II, but you know, at least it's something that the vehicle's going to give you. All right, so you can see the GM ALDL connection right there. That's going to be the one that GM uses, and you can see not everyone's used, so there's not much information coming back to our handheld. And you could see the A and the B one in the upper right hand corner of your screen there, and we're gonna hook up our tool and go from there. All right, so we got the Bosch handheld hooked up to our Suburban, and if I turn it on, it does have an internal battery, and it will run and do all its other stuff. But if we go to vehicle diagnostics, and then we know we've already done it before, so we'll go to our 94x4 V series, click OK. Now it also says, let's see if we can't bring that in a little bit. Cables required, ALDL, cigarette lighter barrel jack. Press enter to continue. Now I've done this before, so I know that this will not work unless I hook up the barrel connector. One reason for that is on OBDI+II, it gets its power from the ECU, but on OBDI+, there's no power on that plug for a code reader or a handheld or anything like that. So we do have to put the barrel plug in there. It's also where it gets alternator voltage from. So we're going to do that, and we'll start this right back up. All right, so we got both cables plugged in, so now we're just going to start the car. Just hit enter. There again. Okay, so the first thing it's going to tell us is, are there any codes on the ECM? So if we were to ground out plug A and B and look at our check engine light and get the flashing and everything, we would get the codes, but this truck has no codes on it. So we're just going to press enter. And we're going to look at the data stream today. I personally know that the thermostat is a 195. When I did the bonus content video of the radiator swap out with all that other good stuff, I put in a new thermostat. So we're just going to hit view data. So there's 21 information streams that we can look at on this vehicle. So we're just going to look at the entire list. And this is going to kind of give us what we're looking at. So there's things you can look at. Fourth gear switch is on, AC request is on. I do have the AC on. The air diverter solenoid, I believe that's also the IAC, or maybe this is the air switch solenoid, I'm not sure. But so you can see the battery voltage is 13.6. That's getting that from the alternator via the barrel plug down in the cigarette lighter. Now I know for a fact that it gives out 14.4, but the wires in this truck are 30 years old, so I'm not going to hold that to Rosetta Stone there. I don't know what clear flood is. The coolant temperature, obviously, engine RPM. Now, the engine RPM, when I have this plugged in, seems like it's always right around 1,000. When I take it out and restart the vehicle, it idles somewhere around 650, 700. So I think that is a product of it knowing that we have the data logger in there. So, exhaust O2, you can watch this go from lean to rich when you're driving. And that's when it's adding fuel, taking away fuel, adding fuel, taking away fuel. The IA position is 90. So there we go. There's the IAC position. Loop status, that's of the fuel solenoids. The map sensor, and that's manifold absolute pressure. And then the O2 switch, you can see the voltage coming off of there. And that's what it's using to mix the fuel with. And then there's the prom ID of the chip. TCC, that's torque converter lockup, no and yes on 700 R4s. The torque converter in 4th gear will lock up, so the transmission will actually lock 4th gear into the torque converter to the output shaft of the engine, giving it a 1-to-1 rotation. Makes it easier on the transmission and the engine. And then what else do we got here? TPS, that's throttle position sensor, so if I give it gas, the voltage will change. And then the vehicle speed, which we're at 0. Now the vehicle speed sensor on this car is in the tail housing of the transmission. I believe it's actually in the transfer case. So as we go forth, it'll actually change. So maybe what we'll do is hook this gauge up into my phone holder. I'll see if I can zoom in on it and we'll go around the block real quick. I do not have a gimbal for this camera as of yet, so if it's a little shaky, I apologize. We're just gonna go around the block and watch the vehicle speed increase or decrease. I'll try to cut down on the wind noise here, but I'm not turning the air conditioner off, sorry. The temperature gauge is wrong. It's reading, I don't know, 165. If we go back up here to our coolant temperature, it's reading at 187. So that gauge ain't right. See the coolant temp get up to 191, and the gauge still saying 155. Manifold absolute pressure, that's a voltage on this, and so as vacuum goes up or down, the voltage changes. So that's just some of the stuff that we can see using this handheld device. If there was a problem, we could look in here to see it. So if we go to back, diagnostic codes, read codes. No codes found. So we can't even look at the codes because it doesn't have any.